my beginner's guide for balancing equations. The first thing that I want to let you know is that there's no magic to balancing equations. There's no secret that you can somehow pick up and all of a sudden become a guru. The reason I made this video is that some students just seem to struggle with how do I even do that, or the concept behind it. And so if you're really having troubles, hopefully I can kind of clear some of that up. And if you're not, this is probably not the video for you. I would just go Google balancing equations practice and you'll find some really hard ones out that you can try your hand at. So let's get started. We're going to start. The first one we're going to talk about is the combustion of hydrogen. This is the Hindenburg explosion, and after this we quit putting hydrogen gas into blimps for obvious reasons. But essentially what happens is hydrogen combines with oxygen. Okay, so if we look at the equation down here at the bottom, the equation as it is H2 plus O2 yields water, or H2O, and we're going to get a lot of energy out of there as well. Now, the first thing we need to talk about is what these numbers actually mean. So this 2 down here is a subscript, and that means that it tells you how many atoms of hydrogen are in a molecule. And so this is what the molecule of hydrogen would look like. We're going to have 2 atoms of hydrogen. The thing that you need to remember is that you can never change the subscripts. Subscripts have to remain the same, because if you change it, you're changing what that molecule actually is. And so this would be H2, this would be O2, so we have 2 oxygen molecules attached together. Then finally we have H2O, and H2O is 1 oxygen and 2 hydrogens on either side. And so when I look at this, a lot of people will just try to go and answer this, but maybe we need to step back a little bit and actually look graphically at what's going on here. And so when I look at this, I can see here's reactants before the reaction and products. And so just looking at it, when these are graphically shown, you can see that I have 2 of these red oxygen atoms on the left side and only 1 on the right. And so the first thing you might want to do is kind of double that. And so let me do that. Okay, so now visually we've got 2 water molecules, and so I've got 2 reds on the right side and 2 reds on the left side. You'll also notice, so that's balanced, that the hydrogens are changed. And so I have 4 hydrogens on the right side, but I only have 2 on the left side. So now let me click it again, and we've got a balanced equation. In other words, I can never change the subscripts. I can never change what these molecules are. But when you're balancing equations, what you're trying to do is add more of the molecules so you can see that reactants and products will be balanced. Okay, now how do we actually write that out? So we can put in front of here what are called coefficients. And coefficients are numbers in front of the molecule. It tells you how many there are. And so there is 1 oxygen, and we never write the coefficient of 1. And so you don't want to write 1 as a coefficient. If it's a coefficient of 1, you just leave it blank. But let's go over here to H2. You've got this H2, that H2, and so you have 2 H2. So that would be on the left side. If we go on to the right side, you have this molecule of water, this molecule of water, and so we have 2 molecules of water on the right side. And so if we step through this, this means we have 2 molecules of H2, so that would be 4 hydrogens on the left side. After you balance an equation, you want to go back and look at it and make sure it's balanced. Over here we have 2 H2s as well, so we have 4 hydrogens. We have 2 oxygens on the left side, and we have 2, this coefficient multiplies times this whole thing, so we have 2 oxygens on the right side as well. And so we would call that a balanced equation. And so hopefully just by looking at it graphically, that might help a little bit. Let's go to the next one. Next one in a chemistry lab is, you see it all the time. This is a Bunsen burner, and these are some flames from a Bunsen burner. And so a Bunsen burner works using a gas called methane, and methane is CH4. So if we take a look at methane, methane looks like this right here. It's got 1 carbon molecule, and then it's got 4 hydrogens attached around the outside. And when we burn methane, what that really means is that we're combining methane with oxygen, and we're creating these 2 things. In complete combustion, we're creating some carbon dioxide gas. That's 1 carbon, 2 oxygens. And then we're creating a little bit of water. The other thing we produce is going to be energy. Okay, so if you look at this just graphically on the left side and on the right side, the first thing, at least to me, that jumps out is that there's way more hydrogen on the left side than the right side. So the first thing I could do would be to add another water on the right side. So if I've added another water on the right side, the yellow balls on the right now match the yellow balls on the left. The carbon, there's only 1 on the left, matches the 1 on the right. And so we must be getting really close. But I've got 4 reds on the right, and I only have 2. And so I have to add that as a whole molecule. So if I add 1 more molecule of oxygen, now we have a balanced equation. So how do we write that out? So methane on the left side, I have 1 methane, but I'm not going to write the number 1. How many molecules of oxygen do we have? We have 2. So I'm going to put a 2 as a coefficient right here. Now on the right side, we only have 1 carbon dioxide, so I'm not going to put a 1, but there should be, in your mind, a 1 there. And then how much water do we have? We have just 2 waters. So I'm going to put 2 right here. Now we could go through the whole thing. So how many carbons do we have? 1 on the left, 1 on the right. How many hydrogen do we have? 4 on the left. And this 2 is multiplied the subscript. So we've got 4 on the right and 4 on the left. And then if we look at oxygen, we've got 4 on the left. And then we've got 2 oxygen here, and we have 2 oxygen there. And so when I'm solving and trying to balance equations, I'm not really seeing these, but if that helps you visualize it, then it'll help you do better at that. So let's try it. So the only way to get better at this is to just practice. And so let's try a few, and I'll show you how I would think through this in my mind. Let's go to the next one. On the left side, we've got sodium, we've got chlorine gas, and then we're making table salt. And so if you want to write this out, you could. We've got Na, and I've got 1 of those. I've got chlorine on the left side, and I've got 2 of those. So that's on the left side. That's on the reactant side. Now let's go to the product side. How many sodium do we have? We only have 1 sodium. And how many chlorine do we have on the right side? Well, we only have 1 chlorine. So that's a problem, because on the product side, we only have 1 atom of chlorine. And on the reactant side, we actually have 2. So how could I fix that? Well, let's try to go back. Let's say I've got too few chlorine on this side. So let me just try and add the next step, which is to add a 2 on the right side. So by adding a 2 on the right side, I've taken care of my chlorine. So on the right side now, I have 2 sodium and 2 chlorine. But I've set up another problem. In other words, I have 2 sodium on the right side, so now I have to balance that over here. So I'm going to come back here and write a 2 over here, which that makes this a 2. Okay, so now we've got 2, 2, 2, 2, and that's balanced. And so the right answer for that one is to put a 2 in front of the sodium and then a 2 in front of the sodium chloride. And that's a balanced equation. Remember, you can never change the subscript. All right, let's do another one. Another one. And so these are getting progressively harder. And so I'll give you some tips as far as that goes. The first tip would be this. If we look at this one, we've got silver sulfide, silver, and then sulfur. And so this 8 jumps out right away. So on the right side, I've got 8 sulfur atoms. If we look on the left side, I've only got 1. And so as a bare minimum, I'm going to try writing an 8 right here. Let's see what that does. Well, now we have 8 sulfur on the left side, 8 sulfur on the right side. But our silvers aren't matching. So on the left side, we actually have 16 silver, but on the right side, we only have 1. And so let me just try writing a 16 down. So now that's a balanced equation. So we could go through 16 silver, 8 sulfur, 8 sulfur, and that's going to be a balanced equation. The nice thing about balancing equations is you can always check it at the end and you know that you are right. It's not like you're maybe right. You absolutely are right as long as you're just adding the coefficients. All right, so here's the ones that are more likely that you're going to find. And so let's work through this and always be patient, remembering that if you get frustrated, you can just erase them all, start over again. You should be able to figure them all out. It's just kind of a guess and check. But let me show you how I would think this one out. So we've got water, carbon dioxide, got a hydrocarbon here, and then we've got an oxygen. And so on the right side, the thing that jumps out to me right away is we've got 7 carbons on the right side. And so what I'm going to try to do is put a 7 over here. Okay, so what does that do for me? Now I've got my 7 carbons taken care of. The other thing that jumps out right away is on the right side I have 8 hydrogens, and water is the only thing on the left side that actually has hydrogens. And so if there's an 8 here, let me try putting a 4 over here. Okay, so what that does is give me hydrogen on the left is going to give me 8. Hydrogen on the right side is going to give me 8 as well. Now I love it when I solve these and I get down to just like one thing left and it has 1 atom in it. And so I think carbons and hydrogens are good on either side, but let me take a look at the oxygens. On the left side we have 4 oxygens, so in this molecule of 4 waters. And then we have 14 here. And so I've got 14 total oxygens, 7 here, and then 4 over here. And so how do I get to, so again, I've got 18 total. And so if I were to put a 9 over here, that would give me, on the right side, 18 total oxygens. On the left side, 18 total oxygens as well. So that would be a perfectly balanced equation. And so that's kind of my starter's guide on how to balance equations. Remember, you can only add the coefficients. You can never change the subscripts. And if you can get confused, start imagining them as molecules and even draw them out if you have to, and that might help a little bit. So I hope that's helpful, and have a great day.